Hello everyone, a very warm welcome to Data Analysis with R. I am Vishwanath Jha, your instructor for this course. So let's see what all things are we gonna cover in this course. To begin with, let's look at the first module that we have. In Introduction to R, we shall learn the fundamentals of R like data types, data structures, operators, conditionals, looping constructs, looping functions, etc. In the next module, Tidy Your Data using tidyr, we will learn how to prepare data for analysis like missing value treatment, outlier removal, pivoting and unpivoting of data sets, etc. In the module Grammar of Data Manipulation dplyr, we shall learn how to create calculated columns, filter, select data sets based on the condition with better efficiency and improved code readability when compared to base R. In the next module, Faster Than Ever Data Manipulation with data.table, we shall learn how to manipulate large datasets on high speed. This is an alternative to dplyr and is really put to use in industry. In the next module, Statistics in R, we shall learn how to perform basic statistical analysis in R. We will talk about data, its distribution, relationship between variables, etc. In our last module, we shall learn how to plot beautiful and high resolution charts to communicate our results. We shall see the do's and don'ts of visualization and also multiple other aspects of it. Let me tell you how this class will work. There is no programming knowledge presumed here. However, if you have some statistics knowledge, it would be a big plus. Also, please keep up with the readings and assignments that you are given. Now it's time to get started. What is R? The basic question that we need to ask ourselves. R is a language and environment for statistical computing and graphics. A GNU project similar to S language developed at Bell Laboratories by John Chambers and colleagues. It is free. Yeah, it is free software under the terms of Free Software Foundation's GNU General Public License in source code form. R provides a wide variety of statistical and graphical techniques and is highly extensible. So, what is an R environment? R is an integrated suite of software facilities for data manipulation, calculation, and graphical display. It includes an effective data handling and storage facility, a suite of operators for calculation on arrays, in particular matrices, a large, coherent, integrated collection of intermediate tools for data analysis, a graphical facility for data analysis and display either on screen or on hard copy, a well-developed, simple and effective programming language which includes conditionals, loops, user-defined, recursive functions, input and output facilities. So now let's talk about a little bit of history, how R actually started. R was actually developed for the first time in 1991 in New Zealand by Ross Ihaka and Robert Gentleman. Subsequently, there were multiple versions of R which were later released. Few important things in the timeline would be the formation of R core group. The core group controls the source code of R. The latest version of R is 3.3.0 and was released in 2016. Why R? Because we can perform statistics and data mining just like SAS can perform for us. We can do technical computing, matrix and vector formulation just like MATLAB can perform. Also, it can perform data visualization and analysis as well as image processing and vector computing just like our other platform IDL can do. So you can see that R can perform everything that these three technologies can do combined together. So let's have a quick look at why we should be using R. So first thing, it is free, it is open source, available on every major platform. A massive set of packages for statistical modeling, machine learning, visualization and importing and manipulating data. Cutting edge tools. Yes, researchers in statistics and machine learning will often publish an R package to accompany their articles. This means immediate access to the very latest statistical techniques and implementations. The deep-seated language support for data analysis. Yeah, R was designed to support data analysis. This includes features like missing values, data frames, and subsetting, which we'll discuss in detail when the time comes. R was designed to connect high-performance programming languages like C, Fortran, C++, Java, etc. Yes, R has a fantastic developers community. It is easy to get help from experts on the R help mailing list or on Stack Overflow or subject-specific mailing list like R SIG mixed models or ggplot2. One important benefit of R is that it has a very beautiful IDE, that is integrated development environment tailored to the needs of interactive data analysis and statistical programming. Yes, powerful tools for communicating your results. There are multiple other R packages which make it easy to produce HTML or PDF reports or create interactive websites. R also provides a strong foundation in functional programming. It provides a powerful and flexible toolkit which allows you to write concise yet descriptive code. R also provides a powerful meta-programming facility. R is not just a programming language, it is also an environment for interactive data analysis. Now let's see what are the drawbacks of R that we have. So much of the R code is not very elegant, fast, or easy to understand. Most users do not revise their code to address these shortcomings. Compared to other programming language, the R community tends to be more focused on results instead of process. The knowledge of software engineering best practices is also patchy. Too many R functions reduce the amount of typing at the cost of making code that's hard to understand and can fail in unexpected ways. Inconsistency is rife across contributed packages even within base R. Learning R can be tough because there are many special cases to remember. R isn't particularly fast programming language and poorly written R code can be really terribly slow. Now let's talk about the design of R system. The R system is divided into two conceptual parts. The base R system that you download from CRAN, and the second is everything else. Our functionality is divided into a number of packages. We download the packages as per our requirements. The base R system contains, among other things, the base package which is required to run R and contains the most fundamental functions. The other packages contained in base system includes utils, stats, datasets, graphics, GR devices, and etc. There are also recommended packages like boot, class, cluster, code tools, foreign, etc. to augment our ability to write a better code in R. There are many other packages available on CRAN. The number goes beyond 7200 packages. Multiple packages associated with bioconductor projects are also available. People often make packages available on their personal websites. There is no reliable way to keep track of how many packages are available in this fashion. Let's talk about few R resources that can be of good help to you. So these are the resources that you will find on CRAN. An introduction to R, writing R extensions, R data import export, R installation and administration, R internals. Few more resources, you can have a look on it. Before wrapping up, I have one important thing to show. Yes, a friend in need is a friend indeed. Stack Overflow is your friend. Whenever you have a doubt, you don't know how to do some particular job, you need to ask your friend Stack Overflow. And how do we ask that? Using tags. So, thank you. We would love to see you in our next section.